Hi students, here we go for the problems. A container shaped like a right circular cylinder having diameter 12 centimeter and height 15 centimeter is full of ice cream. So container of a cylindrical shape, diameter 12 centimeter and height is a 15 centimeter, is full of ice cream. Fully ice cream is that. The ice cream is to be filled in cones of height. It is to be filled in the cone of height 12 centimeter and the diameter is 6 centimeter, having a hemispherical shape on the top. So ice cream is filled with hemispherical shape on the top. Okay, so it is a two combined shape. Find the number of such a cones can be filled with the ice cream. So number of cones that can be filled. So converting. So we are converting the ice cream from the cylinder to the many number of cones. So totally how many shapes are there? Three shapes are there. First one is a cylinder. So cylinder height is the 15 centimeter and radius is the 12 centimeter is the diameter. So radius will be the 6 centimeter. Next we have a cone. Cone height is the 12 centimeter and already we have one more height. So let me cylinder as the 1 and cone as the 2. And the cone radius is actually 6 centimeters the diameter. So radius will be the 3 centimeter and the two areas are different. So let me cylinder as the 1 and cone as the 2. And then another shape is the hemisphere. So hemisphere have only the radius, that is the same 3 centimeter, right? So the number of the cone ice we made will be is equal to the volume in the cylinder, ice cream in the cylinder, right? So number of the cone, let me take it as n. So n into each cone, volume of each cone is equal to volume of ice cream in the cylinder, right? So what is the volume of the each cone? Each cone contains the two shapes, conical section plus the hemispherical, right? So n into volume of cone plus volume of hemisphere is equal to the same volume of ice cream in the cylinder. So this n is what we have to find. So n into what is the volume of the cone? 1/3 of pi r square, right? 1/3 pi r, actually it is a cone is a r2, so it is r2 square into h2. Cone is the h2 plus hemisphere is 2/3 pi r cube, but hemisphere r is this 3 and 3 equal, so let me rotate this as a 2 to the whole cube is equal to the volume of the cylinder. The cylinder formula is pi r square h. So pi and our cylinder radius is the 1 and height is the 1, so r1 square h1. So now let me substitute. So n into 1/3 pi, we don't want to substitute, while taking common outside it will be get cancelled. Pi into r2 is a 3, so it is a 3 square and h2 is the 12 plus 2/3 into pi, don't substitute, r2 is a 3 cube, 3 into 3 into 3, so we will be get cancelled, right? Is equal to pi into r1 is the same 6 square, h1 is the 15. So while taking the pi outside as a common, so take a pi as a common, so whatever we can cancel, able to cancel it, cancel. 4 times 3 3, so take pi as the common, so n into pi into balance is 3 square is the 9, 9 4s are 36 plus 3 is 9, 9 2s are 18 is equal to pi into 6 square into 50. So pi get cancelled. So let me take this n into, so 54 is equal to 6 into 6 into 50. So let me divide here. So n is equal to 6 into 6 into 15 divided by 54. So 6 table it comes for 9, and 3 table 2 times, 3 times, and 3 it is for 5. So n is equal to 10. So therefore 10 ice cream cones can be filled with ice cream, right? So here we go for the next problem. Water in a canal 6 meter wide and the 1.5 meter deep. So consider there is a canal with a 6 meter wide and 1.5 meter deep, is flowing with the speed. So from here the water is flowing with the speed 10 kilometer per hour. How much area will it irrigate in 30 minutes if 8 centimeter standing water is needed? So 8 centimeter standing water if needed, how much it will be irrigated? So first we have to find this cross section area. This cross section area will be like a rectangle, right? 6 on 1.5 meter. So first we have to find that cross sectional area. Then if we, after finding the cross section area, the speed is given, so we can find for 1 minute how much water will flow from. They ask in the minutes, that's why. So we have to change that car also. First let me find the cross sectional area. Area of cross section is equal to, this is like an rectangle, so length into breadth is the 1.5 meter into 6 meter. We will be getting it as a 9 meter square, right? This is the area of the cross section. So speed of the water is given in the kilometer per hour. Actually we need, this is in the meter and this is the minutes. So let me change to meter and minutes. So speed of water is equal to 10 kilometer per hour. If we change, we can change 10 into kilometer to meter is the 1000 by hours to minute is a 60 minutes, right? Okay, so this is, now we change to meter per minutes. So volume of the water flows in 1 minute. So how much water it flows in 1 minute is, water flows in 1 minute is, so this is per minute, the speed is given and the area of the cross section is 9 meter per second. So this cross sectional area is a 9 meter per meter square. So from here within a minute the speed of the water will be flows, right? So it's a 9 into the speed is, just I will multiply and write here as an 10,000 by 60. So let me first cancel, and the 3 table and this is for, so 500 into 3 is 1500, right? So it is equal to 1500 meter cube. So 1500 meter cube volumes will be flow. So for 30 minutes volume of water flows in 30 minutes, just we'll multiple 30 with that, right? 30 into 1500, which will be getting a 45,000 meter cube. So within 30 minutes it will irrigate a 45,000 meter cube. Okay, but they asked to find how much area will it irrigate. So we have found the volume. So this volume of water will be irrigate the area, and they gave the standing water is a 8 centimeter. So we have to change that 8 centimeter into the meter first. So it is given that standing water, just consider as a h as a 8 centimeter, which will be, we can write as the 8 by 100 meter. So volume of water irrigating required area, right? The area only they ask, that is length into breadth. We know what the particular length into breadth. That means height is given here is equal to volume of water flowing in 30 minutes, right? So only area we need. So length into breadth, I will be writing it as an area A. That is what we require. A into H is equal to, that H is what we have written here. It is given as 45,000. We have found it. So let me substitute that. So A is equal to, sorry, A into 8 by 100 is equal to 45,000. So that area is a 45,000 into 100 by 8. So if you divide, we will be getting it as a 5 times 46 to 5, right? So the area is required is 562,500 meter square. So therefore area irrigating in 30 minutes is 5,62,500 meters square with this speed. So first we are finding the how much volume it will use to irrigate. After finding this, they given the standing water, how much the canal standing water, 8 centimeter. So with that into area, right, area of that land. So that was we have found. So area of the irrigation is a 5,62,500. So here we go for the next problem. A farmer connects a pipe of internal diameter 20 centimeter from a canal into a cylindrical tank in her field. So consider one canal is there. From here there is a pipe with an internal diameter as a 20 centimeter. It flows the water into the some circular cylinder which is 10 meter diameter. So this diameter is the 10 meter and the deep is 2 meters. So this height is the 2 meter. If water flows through the pipe at rate 3 km per hour, so the speed is 3 km per hour, in how much time will the tank will be filled? So they are asking the time to fill this tank, entire tank. So if you know the volume of the tank and the speed of this water that flows, then we can find the time with the time t, right? So here the two radius are there. So let me take R1 and R2. So and also we want to change the unit. This meter, this is centimeter, change this to meter, and this meter also, kilometer also, it will change to meter and minutes. So diameter is equal to 20 centimeter. If we change, it will be like a 0.2 centimeter, 0.2 meter we have changed. So the radius will be 0.1 meter. So first we have to find the cross sectional area. This cross sectional is a circle. So this area is a pi r square. After finding with the multiple with the speed, you will get for water flows in 1 minute. So area of cross section is equal to pi r, 2 r radius are there, right? So let me represent it as a 1. So r1 square. So pi, let it be as it is, pi into 0.1 square, that is a 0.01 pi meter square. Okay. So speed of the water is 3 km per hour. Let me change to minutes per meter per minutes. So 3000 per 60 means meter per minute. So you can cancel like 50, right? So it will be like an 50 meter per minute. Then for 1 second, volume of 1 minute, the volume of water flows in 1 minute is equal to cross sectional into this, right? 0.01 pi into 50. So if you multiple this and this, we will be getting it as a 0.5 pi meter cube, right? So we need for time. So let me take that time as a t minutes. The volume of water flows in, let me consider the t minutes is, so t into 0.5 pi, right, meter cube. So for t minutes, how many water is flows will be filling this tank, right? So this volume of this tank will be equal to this volume of this things flows. So cylindrical tank have an radius R2, let me consider as R2, it's a 10 meter they said, so it will be then 5 meter, and height is the 2 meter, right? So volume of water flows in T minutes is equal to volume of water contains in the cylinder. T minutes is equal to volume of water in cylinder, right? This we found like an T into 0.5 pi, and the volume of cylinder is formula is pi into R2 square h. So T is what we have to find, 0.5 pi into R2 is pi square into height is the 2, and we can cancel the pi and let it take 0.5 to the denominator. So T is equal to 5 square is a 5 into 2 by 0.5. It can be cancelled for times 0.1. So T is equal to 5 2s are 10 by 0.1. So one decimal we have to move one more decimal. That means we have to add a 10. So T is equal to, so multiple the 10. So T is equal to 100. So it requires a 100 minutes. This cylindrical tank will be filled in 100 minutes, right? So here actually we have found it after finding the T times, we are compared with the volume of the cylinder. So that how much time will take to complete this volume of the cylinder. We know the height and radius, so it is easy to find the volume of the cylinder. So we are comparing the both and we are finding it. Thank you.